Hey everybody, this is a video for my 30S Pre-Cal students. We're going to start today into Chapter 4, and this is going to be a very easy start for most of you because we're kind of starting this chapter with something that we've already covered really kind of twice this course, which is factoring. But specifically, we're of course going to be using factoring to solve quadratic equations. So let's start out with just a very quick factoring review. And when I do this with the class, obviously people watching this video aren't in school today, but the people who are in school, I am going to basically just ask them. I'll give them, say, give you 20 seconds, try factoring this. So feel free to pause the video as we go here and try factoring these for yourself. So pause the video, see if you can factor this one. All right, go. How'd you do? Hopefully you realize that with this kind of factoring, all you're doing is looking for the greatest common factor, and in this case it is 5x squared and 1y. So there we go. So that's the greatest common factor. When I factor that out of the first one, I will get an x. When I factor it out of the second term, I'm going to get a minus 3y, and when I factor it out of the third term, I'm going to get a plus 6 x squared y. Is that a 5? I can't see that far. Yep. So y to the 4. And there we go. So that's greatest common factor factoring. And remember, you always look for this first. Okay, now why don't you take again, I'll give yourself 30 seconds and see if you can do the difference of squares. On your mark, get set, go. How'd that go? Did you get that this is x plus 6, x minus 6? This one is going to be 3y plus 10x squared, 3y minus 10x squared. And this one is messing with you. That is not a difference of squares, it's a sum, so this does not factor. Okay, give yourself 30 seconds and see if you can factor those two simple trinomials. On your marks, get set, go. Did you get that this one is x plus 5, x plus 2, and this one is x plus 5, x minus 3. We've been doing lots of this stuff. And finally, this one I might give you a full 30 seconds just for this one. Can you use your decompositional strategy to factor this one? All right, on your mark, get set, go. All right, how'd that go? Did you realize that 5 times negative 6 is negative 30, so you need to decompose 13 into two numbers that add to make 13, but when you multiply them, you get negative 30. It's probably real easy to think, oh, it's 10 and 3, but no, it's not 10 and 3. It's positive 15 and negative 2. So I'm going to decompose 13x into 15x minus 2x, and then I'm going to partially factor, so I take 5x out of this one, and take negative 2 out of that one. And if these two brackets aren't the same, something's going wrong, or perhaps it actually doesn't factor, but this one factors just nicely. So there's a quick factoring review, which again, I don't know how much we really needed. We've done quite a bit of factoring already this year. And as usual, you know what those words mean already. Let's skip that page. And let's go to this page and fill in some notes. A quadratic equation is any equation that can be written in the form y equals ax squared plus bx plus c. And that is a second degree equation where a, b, and c are constants, and a is not equal to 0. Constants is a good word, and also another word would just be, they should be any real number. Obviously, we can't be playing with imaginary numbers with a quadratic equation, at least not in the coefficients and constants. The graph is, of course, called a parabola. Here's a couple below here just to look at. Aren't they pretty? And obviously, you can read x-intercepts off a graph, but the drawback is, well, where exactly does that cross the x-axis? I mean, it's approximately 0.5 for the first one, and I don't know, that's past the halfway mark, so I'm going to just estimate that it's 5.7, approximately 5.7 for the second one. And for this one, the approximate intercept here would be negative 1, negative 2, negative 3, I don't know, approximately negative 3.2, and approximately 1 to 3.1, or maybe 3.2 again. Maybe that one looks kind of symmetrical, so those two would probably be the same. Of course, we've already seen in Chapter 4, remember this course is actually designed so you could do this chapter before the other chapter if you really wanted to. And we saw in the last chapter that we would have strategies to find exact values for these intercepts. We could find the vertex first and then use a point and find the equation in vertex form, and then set y to 0 and use algebra to solve these points, and I wouldn't just be estimating them now, would I? So we've seen this stuff already, so that's why we're going kind of fast here. And of course, now solving quadratic equations means that basically you've set y to 0, or you have 0 on one side of the equation, and the other side has to be factored. We've talked about this a few times. If you have an equation in this form where you have 2 factors equal 0, you have to consider that either this factor could be 0, or this factor could be 0, since 0 times 0 is 0, or 0 times anything is 0, or anything times 0 is 0. So there's 2 solutions to this equation. X is 9 and x is negative 3, right? 9 would make this factor 0, negative 3 would make that factor 0. If you have a quadratic that looks like this one, obviously x has to be 0 and the other x has to be negative 12. This one, obviously I have to factor first. Again, take 10 seconds. On your mark, get set, go. Did you get it? X plus 7, x minus 4. So my x is negative 7, or my x is 4. And this one, you use your greatest common factor. Oh, I guess I didn't pause to let you try it yourself. Sorry. X is 0, x is 7. And the answers to quadratic equations are also called, they're called zeros often. They're also called roots. And sometimes they're just plain old called solutions. And of course, you already know that graphically they're called x-intercepts. Okay, moving right along. More factoring practice. Here's some factoring at a little higher level. This is maybe a little bit higher than what we've done so far in the course. And again, let's see, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 questions on this page. Take 30 seconds per question. Take 5 minutes. See, this is almost like a mad minute from elementary. See if you can factor all these in 5 minutes. On your mark, get set, go. Okay, did you get them all? Did you get most of them? I do have some bad news for you if you're struggling with these. You know where all of these questions came from? They actually all came from the grade 10 workbook on factoring that if you went through MEAP with us here last semester or last year or wherever, then you have for sure seen them all before. Those of you who came from Leach or Acadia for your grade 10, I honestly don't know how far you went into factoring, but I'm assuming that nothing here should have been completely brand new to you. So anyway, A and B are both differences of squares, so they both make conjugate pairs. Check those out. The next couple here, B and C. The C is a one that I would do by decomposition. I didn't actually show my work. I kind of just did it in my head. But D, we're going to use that, and they don't give me much room here, sorry. We're going to use that that strategy that we called substitutional strategy that we saw last unit, where rather than expanding these things, which we could, but it's kind of a waste of time, we'll just let these two brackets be represented by a letter like A, and then I'll factor it with the A, and then I'll plug what the A actually equals back in once I'm in factored form. And since A was x plus 3, 2 times A would be 2x plus 6, and A minus 3 would be x plus 3 minus 3. So my final answer is 2x plus 1. All right, for E and F, well, F is just a difference of squares again, but that decimal shouldn't scare you. We've talked about that already in class. Decimals can be perfect squares, and that decimal actually is a perfect square. And for E, I go back to rule 1 of factoring. Factor out a common factor. I know you're thinking, well, there isn't really a quarter common to these three things, but it can be. Take a look at what happens if you factor out a quarter. You get something very nice and easy to factor, because if you factor a quarter out of 1, it leaves you with 4, and if you factor a quarter out of 3, it leaves you with 12. That's such a nice trick. That works so well. I'll bet there's some people who didn't get that one. And there we go. There's E and F. Okay, so now that you've seen that trick in E, it works exactly again in G. We're going to factor out a half. And when we do that, we are going to get that, and of course the h1 on the right is just difference of squares, again with a decimal that you know is a perfect square, and g factors out quite nicely. And finally, the last couple here, I and j, let's use our substitution trick again. We've seen one actually exactly like I in the chapter 6 booklet, so that shouldn't be news to you that that's a difference of squares, and then you put a and b back in, do a little bit of arithmetic, and there's my final answer for that one. J took me a little more work because I had to factor a -2 out of everything, and there's my final answers for both of those. There is our quick and messy factoring review. 10 minutes, perfect. Now let's use factoring to solve equations. And again, we've done this before. This isn't news to us, I don't think. But here we go. Why don't we do the same thing again? Let's see, there is 1, 2, 3, 4, 5, 6, 7 questions, 30 seconds per question. That is 3.5 minutes. Why don't we see if in 3.5 minutes you can solve all these by factoring. So on your mark, get set, go. And time is up. How did it go, peoples? Okay, so let's see. From the top. A, the first thing you would do is move that 6 to the other side of the equation so that 0 is on the right. Then I have a fairly easy one to factor, so my answers are -3 and 2. For B, I don't care how you do this first. I actually like moving the number over first, and then I factored out a 2. And remember, this is an equation, so on all of the ones on the last page, that leading coefficient that we factored out has to stay in the final answer. But in this case, it's an equation. Divide both sides of the equation by 2. What happens to the 2? By 2. It's gone. So I just factor that, and I get -4 and +3. So those two are fairly easy. These get harder. This one, I would move the 3x squared to the other side where it becomes positive, and then I did this one by decomposition. I didn't show my steps, but I got it. It's 3x minus 2 and x plus 2, and I did make a little mistake. There's an eraser shaving. And so now this one, be careful. Remember, this thing equals 0, so that means 3x can equal 2, and x is equal to 2/3. Yes, when you factor, you can get fractional answers, even though there weren't any fractions in the equation. Now for this one I actually did have to really think about it. That's a big decomposition one. 4 times 1872. I had to do some scrap work, and I couldn't do this one in my head. So I realized 72 decomposes into -24 and +3, and that factors down to 4x plus 3 and x minus 6, which takes me to x is -3/4 and x is 6. Phew, that one took some work. I had to think about that one. Okay, moving along. Let me move up here. All right, for these two, I used, on the one on the left, I used my factoring. I factored out the fraction. If I factor a 12th out of 3, I get 36, because that would be 3 divided by 1/12, which is 3 times 12. So once again, just like in the last example, I can just, or like in the B example, I can just divide both sides of the equation by a 12th, and then factor that into a difference of squares. And yes, when the zeros are the same number, just plus or minus, you can save some writing and just write it as x is plus a sixth or minus a sixth. For f, again, it's an equation. I can multiply both sides by the same thing, and it doesn't change the equation, so I multiply both sides by 100. There, decimals be gone. And then from there, I divided both sides of the equation by 2, and then I had a nice difference of squares. So I got x is plus or minus 1/5. Finally, last one for the day. I'm glad, oops, don't want to reveal too much. I'm glad there's one like this, because I will get the occasional student who thinks they can factor right here. They think, oh, okay, what number, this number could be 6 and this number could be 4, and that's 24. But yeah, but wait a minute. Couldn't this number be 4 and that number be 6? Couldn't this number be 12 and that number be 2? Couldn't this number be 21 and this number be 1? That is no way to factor. Step 1 is that the right side, or one side of the equation, has to be a 0. So that is what we have to do first. We have to actually expand the left side and then move the 24 over so that we get x squared plus x minus 30 equals 0. I don't know why I'm hiding things anymore. There we go, and there's the final answer. We get x plus 6 and x minus 5, which means x is -6 and x is 5. You're obviously not working in the textbook. There is a nice little assignment with some more factoring practice in the Chapter 4 workbook. Thanks for watching, everybody.